Welcome to qnawire.
The null hypothesis would be that the average number of charges is not more than 1,000, which would be or equal to 1,000. So the null hypothesis would be that the mean is less than or equal to 1,000, and the alternative hypothesis is that the number of charges is more than 1,000. So mu is greater than 1,000. This would be a one-tailed test, specifically right-tailed because we're dealing with greater than 1,000. We would use a z-test here because the sample size is large, and the formula for the z-test statistic is the sample mean minus the hypothesized mean over the sample standard deviation with the square root of the sample size. And so substituting what we know, the sample mean is 1,002, the hypothesized is 1,000, the sample standard deviation is 14, and the sample size is 100. Calculate this, and we get about 1.43. Then it says we can do either the p-value or the critical information. Well, with a significance level 0.01 for a one-tailed test, a critical z is 2.33, and this comes from the standard normal distribution table. And using a z-score of 1.43, and if you did a p-value, you'll get more than 0.01, but since our test statistic is smaller than our critical, we're going to fail to reject. The null hypothesis. So there is not enough information, or not enough information, but not enough evidence at the 0.01 level of significance to support the manufacturer's claim. That the batteries last for an average of more than 1,000 charges. And the reasoning will be that the test statistic, and if you were to give a p-value, would both indicate that the sample mean of 1,002 charges is not significantly higher than the claimed average of 1,000. And this could be due to random variation rather than a true increase in the mean.